Hello, I'm Tom Nahumi from Dell EMC. In this demonstration video, I'll be showing the Dell EMC PowerStore CSI 1.2 new features. The CSI driver for Dell EMC PowerStore implements an interface between CSI-enabled container orchestrator and the Dell EMC PowerStore storage system. It allows dynamically provisioning PowerStore volumes and attaching them to workloads. The highlights of this release include support for OpenShift 4.5 and 4.6 with both RHEL and Red Hat CoreOS worker nodes, support for RHEL 7.9 and CentOS 7.1, as well as Ubuntu 20.04 HostOS, support for Docker Enterprise Edition 3.1, topology, inline ephemeral volumes, controller HA, iSCSI CHAP secrets, and reuse of host entries for both FC and iSCSI initiators. With that, let's start. Version 1.2 of CSI PowerStore introduces controller HA feature. Instead of stateful set, controller pods are deployed as a deployment. The user can adjust the number of replicas and number of node tolerations by editing the values.yaml file. When multiple replicas of controller pod are in a cluster, each sidecar tries to get a lease, so only one instance of each sidecar would be active in the cluster at a time. As you can see, I'm running OpenShift 4.6.4. By navigating to the Deployments tab and selecting the CSI PowerStore namespace, we can see that the controller pods are deployed as a deployment instead of a stateful set, running the CSI driver and the sidecar containers. I can scale up or down the number of replicas, as this feature allows us to provide HA for our CSI driver in a case of a node failure. The PowerStore CSI driver version 1.2 and later supports topology, which forces volumes to be placed on worker nodes that have connectivity to the backend storage. These cover use cases where customers have chosen to restrict the nodes on which CSI driver is deployed. In these scenarios, volumes will be mapped only to nodes that have connectivity to the PowerStore array. By describing the PowerStore topology storage class, we can see that this storage class matches all nodes where driver has a connection to PowerStore with this IP via iSCSI. By running the kubectl get nodes --show labels, we can see that our OpenShift worker nodes have the same label listed in the storage class. For the purpose of this demo, I'm going to create a new 32 gig PVC from this storage class. By running the kubectl describe PVC command, we can see that the PVC status is pending. This is because the volume is waiting for the pod to be created before the binding. Once the pod request is sent to Kubernetes, it will place the pod on the node that has connectivity to the PowerStore array and bind the volume to it. Starting from version 1.2, the PowerStore CSI driver supports the ephemeral volume workload. CSI inline ephemeral volumes allows you to define a pod spec that creates inline ephemeral volumes when a pod is deployed and delete them when a pod is destroyed. In order to use this feature, the CSI driver object must exist in the cluster and support for ephemeral workloads must be specified inside it. This feature allows you to specify CSI volumes directly in the pod specification, rather than in a persistent volume object. Inline volumes are ephemeral and do not persist across pod restarts. As you can see, I specified the volume definition inside the pod YAML file and set a driver to our PowerStore CSI driver. By running the kubectl create pod command, you can see that in addition to the pod creation, a new 2 gig volume has been created. If I navigate to the PowerStore UI, I can see that a new ephemeral volume has been created and mapped to the Kubernetes worker node. This volume is automatically deleted once the pod finishes its life cycle or destroyed. The next feature is iSCSI CHAP. Version 1.2 adds support for iSCSI CHAP authentication for iSCSI protocol. The driver uses the provider CHAP secret to configure iSCSI node database on each node with iSCSI access. In order to enable CHAP authentication, first of all, we need to create a secret called PowerStore creds with the key CHAP secret and CHAP user set to base 64 values. Then, we need to set a parameter connection.enableCHAP in myPowerStore setting YAML to true, and then, once CHAP is enabled at the PowerStore array level, by creating new hosts on the PowerStore array, the driver will populate host CHAP credentials with the provided values. The next feature is reuse PowerStore hostnames. Since version 1.2, the driver can automatically detect if the current node has already been registered as a host at the PowerStore array level and reuse previous names instead of failing the deployment. During the CSI driver deployment, the installer checks for each Kubernetes node if the host already exists. If it does, the installer doesn't create a new host and takes the existing name of the host as a node ID for the Kubernetes worker node. I really hope you find this demo useful, and thank you very much for watching.